Hi, my name is Alex Williams, founder of the NewsStack, and you are listening to the NewsStack Analyst Podcast. We look at application development and management at scale. IBM is a series sponsor of our ebooks on Docker and the container ecosystem. Learn more about IBM's perspectives on these timely and important topics in our latest ebook about networking, security, and storage. It's available for download at thenewstack.io. Now let's get to the show. Hey, it's Alex Williams of the NewsStack here with Phil Estes. And Phil, good to see you and talk a little bit about the Docker and container ecosystem. One of the aspects of this new ecosystem is about the mysteries around security, and I don't think people really understand the concepts about security, especially in the context of containers, where it's a process, right, and really not a machine, right?
Right.
And so perhaps what you can do is help us kind of provide some historical context for container security, and then perhaps we can then use that as a framework for what we're seeing today and what we're going to expect to see over the next 6, 12, 18 months.
Right. Yeah, sure. So I think, one of the most interesting things, if you walk back a little bit, is that even in Solomon's keynote this morning, Docker didn't come out of sort of the ether. It's out of a set of work that's been happening in Linux for a very long time. People like Google, IBM, and others have sort of evolved the components that we think of as a container in Linux. Didn't appear sort of on day one. And I think people coming to that world from something very concrete like a virtual machine, we know what it is. It's based on this hypervisor. We know sort of that separation layer, why it's secure, what its capabilities are. And then you come back to containers and you see that, in essence, the isolation pieces of how why we even call it a container, really came about over a period of time. They sort of evolved from this idea of control groups and namespaces. And so these concepts, for one, are not as well known as VMware and VirtualBox. Those are kind of concrete, understandable things to a lot of people. Whereas these low-level, kind of murky Linux kernel features, aren't as understandable to the general public. And so, I think what Docker and others have done is really assemble them into something where people kind of have a better understanding of, how is it isolated from other processes on my system? What are the additional knobs you give me for security controls, and now, I guess if we want to walk through, just in 2015, 2016, Docker and other container executors have added things like secure computing, which is, again, a Linux kernel feature that allows you to very finely tune what a process is able to do as far as calling into the kernel. And then things like user namespaces, which I worked on, which makes the user inside the contained process not the same as the root user outside the contained process. So basically mapping to IDs that aren't even understood on the general host. AppArmor, SE Linux. So there's this whole set of components that, again, all come from Linux kernel features, or the distros have packaged them in a way that now Docker, one of the great things I think they've done is turned on many of them by default. So as someone new to the Docker ecosystem, when I type Docker run and my container, I don't have to know that it's running AppArmor and seccomp and user namespaces. There are sane defaults that people put in place that make my process immediately more secure than just running it on my host. So I think we've seen a lot of valuable improvements and additions to security just in the last year alone. And as more and more companies and partners and researchers get involved, we're seeing the Linux kernel add more controls and capabilities that in essence are only making security a better story for containers all the time.
So where is the evolution of usernames and in the namespace kind of story?
So user namespaces, again, so if you look back at Linux, or if you go to kind of a Containers 101 talk, they'll talk about the mount namespace and the PID namespace. Well, user namespaces were kind of the last piece of the puzzle that were put into the Linux kernel, I think, finished in 2011, 2012, and then have now come into Docker. They've also been exposed in LexD from Canonical, so it's a core component of the Linux kernel that any container system could exploit, and now Docker supports it and runs C and LexD. Where we're trying to go is where basically every either tenant or even every container could basically have its own set of user IDs and group IDs, such that if it were possible to break out of your contained process, your permissions on the overall host would be useless. You're not root, you're not an administrator, and so user namespaces really provides that next set of isolation that keeps you from being able to even read files. Anything that's owned by root on the real host, you're not going to be able to use as the contained user. So there are basically a set of work items around that continue. Even in the Linux kernel, there are improvements to user namespaces coming, like the ability to map file systems. So in Docker, you share layers among all your containers. Well, now if I want container B to have a different user namespace than container A, they need to see the files with different IDs. And so, again, there's low-level work going on in the Linux kernel and Docker to make that a reality, so we can keep sharing file systems, but everyone has their own ID space that protects them from having access to other people's data.
How low level are we talking about?
So, I mean, there are patches on the Linux kernel mailing list. Eric Biederman is kind of seen as the father of user namespaces in the Linux community, and so, he's continuing to refine and improve that whole user namespace capability at the kernel layer. And then, again, people in the Docker community and other container communities can then exploit that, given, as usual, the trade-off is now you have to require newer Linux kernels to exploit some of the newest features.
So how would you characterize the state of security today in the container ecosystem?
Again, I may have a viewpoint, again, coming from someone who's very actively in the ecosystem. I would say that again, we have IBM research teams that are looking at every aspect of the Linux kernel and containment. We have, Docker has a security team who has been doing significant amount of work with trusted images, image signing. So when you add all these components together, I think I would say it's a very positive picture right now, as far as if you go back 3 years compared to what were the capabilities you had for security then versus now. I'd say things have improved considerably, and Rob Hirschfeld recently wrote a blog about
13.
Yeah, the 13 ways that containers are more secure than VMs.
Do you agree?
I do. And again, the interesting thing about Rob's blog is that the onus is not all on the container execution layer. My application has to do smart things about how I use data, how I set up, how do I pass any kind of cryptographic keys or settings or passwords. So, as usual, security is a shared task for application developers. The container community, I think, is taking very seriously their side of that equation, and a lot of good information is available to app publishers and creators to make sure that together you can really make containers, in essence, a potentially more secure resource than even a VM.
So, what's the work that you're doing now at IBM?
Yeah, so there are a couple things I'm focused on. One, I just gave a talk at lunchtime in the community theater about multi-platform images in the Docker registry. So today, IBM's done a lot of work to bring Docker to our System Z and Power platforms. There are folks here at the conference from ARM, from Linaro. There are Raspberry Pi aficionados who are running Docker on little embedded boards. But currently the Docker registry, or at least in recent history, the Docker registry hasn't supported a way to kind of define this image is for an ARM system, but I wanted to have the same name as the MySQL image that a standard Linux laptop user would pull. And so I've been working with the Docker distribution team on the new image spec and new tooling to be able to create images with the same name, that when I Docker run on a Power server or System Z or my Linux laptop, the engine knows which layers to pull, which go with which architecture. So that work has actually progressed quite nicely, and I think we're hoping to see the Docker Hub user interface and everything fully supports multi-arch in the near future, because that's both important to IBM and the community. And then, as I said, there's a lot of work left in using namespaces, in tenancy around providing different tenants, different user namespaces to keep improving isolation for users. So those are two of the main things I'm working on these days.
Now let's take a quick break before we get back to the second half of the show. IBM is a series sponsor of our ebooks on Docker and the container ecosystem. Learn more about IBM's perspectives on these timely and important topics in our latest ebook about networking, security, and storage. It's available for download at thenewstack.io. Now let's get back to the show. What happens in terms of the complexity when we start thinking about orchestration platforms and microservices architectures, and now the volume of containers increases exponentially. You have thousands of containers potentially on a host, right?
Yeah. Obviously, even here at the conference, you can see that even though there are folks like myself and others working at the lower layers, a lot of the focus is turning to who's providing the best, orchestration, who's providing the best tooling for handling the volume of, if you've got 1,000 containers on a host, who's going to track all that log data, where's it going, who's collecting it, and obviously from today's announcements and the keynotes, Docker themselves are very intent on providing the best possible orchestration in Docker itself. It's potentially a confusing area for customers because how many companies and vendors are offering solutions, but I think there's going to be a lot of innovation obviously in that space. We've been running a public cloud at IBM with a container service based on Docker, and all the things that we've experienced trying to operate that cloud, I think, are the same things that people trying to move Docker into production are seeing, which is the whole life cycle of containers, anything to do around log visibility, and obviously if you're going to do any kind of tracking of usage, so for billing, that whole area is a little more complex. VMs were very straightforward. They're either running or they're not running.
So take us through that process and what you've learned.
I think there are probably other experts that have spent the last couple of years trying to figure that out. I can give some high level thoughts about that. One is that the technology is moving quickly, and that makes it difficult to sort of stay with a certain solution. So even our own container service has evolved at least every few months. So Docker adds a new feature for pluggable logging drivers. Well, maybe we'll move our logging platform to utilize this new feature. And networking was a very basic capability in early Docker releases, and now you have a huge number of options from overlays and SDN. So I think part of it is trying to map what your customers' needs are to what particular pieces and solutions. So there's a funny image that I think has been shared on Twitter a lot of, Docker on my laptop is just the Docker engine, and then it says, the cliff of learning is now there's about 20 things I have to think about once I move off my laptop into production. Everything from how I'm going to deploy, what tools are going to track where my containers are running, logging, network, and so I think those are things we've had to consider, and that's really what the whole community is trying to understand as they move from, hey, Docker's great, containerizing my app is easy, but now how do I actually monitor that, track it, log it?
The monitoring, the tracking, the logging, in the upstream community, what are the focuses there?
One of the focuses, and I think there probably is a talk tomorrow, it hasn't been mentioned as much today, but at least in Docker itself, there's been a big focus on pluggability because there's so many options for logging drivers, logging frameworks. The Docker engine itself shouldn't be in control of that. That should be a pluggable component where if I'm a log service provider, I should be able to plug into that. So I think because a lot of these areas are fast moving, Docker has chosen that pluggable model so that vendors can put those pieces in instead of having the engine try and keep track of all those technologies and have specific drivers and updates and all that.
So when you think about the evolution of the Docker and container ecosystem, how do you compare it to other other communities that are developing microservices environments and orchestration platforms? In particular, there's Kubernetes, which is has a very vibrant open source community. What is comparable or and different in the upstream communities? When you think about Docker and kind of Kubernetes as examples.
One of the things that's interesting to watch is just how, Kubernetes has grown to be, as you said, a very vibrant community, in essence built around the Docker engine. Then you've got Mesos and other orchestrators, almost all of them, having open source communities and open source projects around them, which, IBM perceives as a great thing as far as the fact that, the way much of this activity would have been done in proprietary, systems and inside the walls of a large company. We're able to take advantage of that. So we have people involved in the Kubernetes ecosystem. We have people contributing to Mesos. We obviously have Docker contributors like myself. We see there's great value in kind of the interplay of these communities. Understanding there's also competition, and there's also, many of these are based around a company or a startup who's also looking to monetize these spaces. But in essence, we see the open source component to that as being valuable, such that there's a lot of good interplay of ideas and innovations.
What are those interplays?
For one, just by nature of open source, there's a natural sharing of ideas. So if Docker comes out with a way of doing volumes and that's valuable to someone else, they can simply take. So, a lot of the components of Docker are open source projects in and of themselves that are reusable, and so you see Docker including other open source projects with libraries that Go libraries for talking to a key value store, and whether that was written by HashiCorp or CoreOS, there's all this sharing of sort of these underlying components, and so that kind of interplay I think is very valuable. That has existed long before the container ecosystem, the Linux communities, and all the open source kind of history that predates that.
With Kubernetes, an orchestration platform that's growing fast, and the Docker community is growing fast, and the overlap there. What are some of the concerns you have about maintaining security kind of across those different platform environments?
Yeah, so the interesting thing is that today Kubernetes pods are executing the Docker engine. That's what's actually running the containers, and so there are folks in that community who know that the engine needs to be configured in such and such a way to have these security features enabled in Kubernetes. And there's even been issues and pull requests across those projects to make sure that certain things are enabled the same way or with the same capabilities. There's obviously potential that Kubernetes may use other container executors like Rocket and potentially OCI and runC in the future. But the nice thing is that at that very lower layer there is a lot of coordinated efforts like the Open Container Initiative, making sure that there's sort of a common base of the namespaces we talked about, the control groups, the secure computing, user namespaces. Those are all kind of in that specification, such that hopefully no matter who you're going to pick as your orchestration provider, your containers will use the same security.
Runtime, yeah, so it shares that.
Right.
What are the areas where it's a question mark, where they're not shared?
Yeah, I guess you could say at the higher layers, and areas like networking where there currently are different implementations. Those will be interesting areas to watch as far as how they evolve in, who will provide maybe better capabilities or better security, but that's sort of yet to be seen.
How does that affect the security story?
Yeah, so again, like we said, I think at the sort of pure container process level, I think there's a lot of similarity and a lot of commonality. So we'd be talking more about application level security and how they connect to the network and who has permissions to change the network configuration. So it'd be at the higher sort of application coordination layers that I think we'd see maybe differentiation or maybe one would be better than others.
In conclusion, I'm interested in looking forward about, what your vision is, what you see the community's vision is for the direction of security, in these complex orchestration environments.
So again, with my focus, I think there's some interesting work going on, again, at the lower layers on fully unprivileged containers. So that's an area where...
Tell us about that.
Yeah, so, Jess Frizzell, who was formerly at Docker, she and I worked together a good bit on some of the user namespace work, and she was exploiting that in some of her fun talks with desktop containers. Right. So she's been digging into, and others, basically a way that I can execute a container as a normal user on my system without ever needing root access, which today, even though I may have user namespaces enabled, I still need to be root on that system to get that container started. And so in a fully unprivileged container, I, as an unprivileged user, can start a container which is in its own user namespace. And so there's much less sort of surface area of attack because I was never root at all in any of the container initialization. So that's an interesting area. And then unikernels is also another potentially interesting area.
How so?
Just in the sense of a very tightly packaged image. So when we think of a container, again, thinking back to Rob's blog, so my application may be secure, but maybe I packaged it in a container that has a gigabyte of hundreds of packages that for some reason other processes are running. I've run some kind of supervisor and other things have started, a SSH daemon, which again, most people would not recommend. But in a unikernel, the only executing code is what you packaged. And so in essence, there may be some interesting things there, but there are also some complexities to that as well. So we'll have to see where that goes.
The whole concept of unprivileged containers is relatively new, isn't it?
Yeah, I mean,
mean,
it's been...
It's always been there, but
Yeah.
it's now getting more attention as a topic.
Yeah, it's getting more attention, and people are figuring out what are the sort of last mile problems, because there's some difficult issues with. There have always been things on Linux that you need root access to do, and so trying to figure out what those are and what the, can there be a sidecar process that configures this network interface so that I don't have to have the privilege to do so.
So now finding kind of other ways to do the same thing, but
right,
almost
without me ever having to become root
right,
to do that.
Right.
So.
You basically kind of, stage it in a way.
Yep.
Yeah. Well, Phil, thank you so much for taking some time to talk. It's been interesting hearing a little bit about this. I think it's an area that we're still trying to learn quite a bit about. So appreciate your time.
Sure.
IBM is a series sponsor of our ebooks on Docker and the container ecosystem. Learn more about IBM's perspectives on these timely and important topics in our latest ebook about networking, security, and storage. It's available for download at thenewstack.io. Audio editing and sound design for the Newsstack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again, and hope to see you back at the show. Bye-bye.